Phosphorus is one of the key elements in food production, and currently we are transporting from around the world most of the phosphate rock we require in Europe for fertilizer production. And this is not only politically and economically unsound concept, but it also involves major environmental impact. Besides causing significant damage in the mining process, it also introduces heavy metals and radioactive compounds that are released in the mining in the fertilizer product and finally end up in our food chain. So to regain the independence in food production and to utilize existing waste streams, phosphorus recovery from wastewater and manure has gained more interest these days. One of the most common ways to recover phosphorus from these streams is the precipitation of magnesium ammonium phosphate, known as struvite. However, struvite recovery involves a lot of disadvantages. One of them is that it requires additional treatment step, meaning extra energy input. It also requires addition of extra magnesium, meaning extra chemicals. And currently, the Dutch legislation prevents the use of struvite in agriculture that is recovered from these waste streams. So this means that at the moment we are piling up the produced struvite in our storage rooms. And also, we are not able to use that struvite as raw material in fertilizer industry because of the presence of magnesium and ammonium. So, to overcome these issues, we have created an alternative way to recover phosphorus locally. In this concept, we recover phosphorus as calcium phosphate granules inside the anaerobic reactor operated on black water. So firstly, when we use black water instead of normal sewage or manure, we involve less toxins in the process. Also, we do not need additional treatment steps since we will precipitate these granules inside the sludge bed of this anaerobic reactor. And most importantly, since we will recover phosphorus as calcium phosphate, we do not need to add magnesium because calcium is already present in black water. And most importantly, we can use these calcium phosphate granules as a raw material in the fertilizer industry because calcium phosphate is the effective composition of phosphate rock. Also, the porous structure of these granules has a higher bioavailability for the phosphate compared to phosphate rock. So we need to add less phosphoric acid in the fertilizer production. And this also means less chemicals. So to conclude, with these granules that I have here in my hand, coming straight from the toilet water, we can recover locally phosphorus as calcium phosphate with lower input of energy, lower input of chemicals, and higher market value compared to struvite. Thank you.